All right, question 1, the acetal question. Now, I pointed this out in the hopes that it would kind of give you a hint that this is a reversed version of our normal look at an acetal. Normally we use an acetal, we're covering up a carbonyl group, an aldehyde or a ketone. That's not the case here. We're flipping it on its head. Normally we're covering up that aldehyde or a ketone by using a diol, which then forms the acetal. Well, we're looking at this in the opposite direction. We have the diol right here. And that's what ends up as the acetal. So what's missing in this is a carbonyl group, specifically a carbonyl group from these atoms right here. So that is a carbonyl between two methyl groups. That's acetone. So this is our carbonyl group to make that particular acetal. And an acetal requires the ketone or aldehyde, the diol, and it requires an acid because this is a protonate-deprotonate type mechanism. So we don't have to specify which one. Probably it's going to be sulfuric acid or a sulfonic acid of some form. But given the complexity of the structure, the exact one may be a little different. And second part of the question here, why would I do that before I make the ester? Because I want the ester in one spot. Esterification can happen when you have an alcohol. Esterification is faster with the primary alcohol, but it's not a selective reaction. So secondary alcohols, these same two in the circle here, could form an ester as well. So I would get esterification on those where I don't want it, because I'm not going to take this ester back off. It's there in the final drug. So I do not want to have any problems with that, because I couldn't remove one in the presence of the others as easily as I might like. It is possible, but it's also difficult. All right, so acetone, some acid source, will give us that acetal, and just to prove that we're on the right track, here's the synthesis. It is acetone and sulfuric acid. That's it. So the base is added to that to neutralize the leftover sulfuric because the brackets here indicate it wasn't isolated. It was just taken forward in the next step. That's why there's no yield given here. So that's why the extra step is here. You don't have to worry about that. I didn't write it the same way. All right, so exactly the conditions you would expect. And again, this is not hypothetical. This is not just some textbook example that may or may not represent current reality. It's not an old example. This is the conditions that are used right now. Right? So, hasn't changed. Same concept as we learned, same reagents we learned.